like to give you some updates about the ongoing work regarding the curation of the chemical methods ontology, CHMO, and the development of the vibrational spectroscopy Vibso before then Noor takes over, saying a few things about NMR-CV and what we're doing in this regard. But let's start with CHMO. Last year, during my Ontologies for Chem status update, I told you about some current issues of CHMO, mostly about those that revolve around harmonizing terms with OBI, and that since CHMO is considered an extension of OBI, we need to make sure that it's always kept in sync with OBI. And as a possible solution to resolve these and other issues, I propose to maintain the curation of CHMO using the Ontology Development Kit, or ODK for short. Because with an ODK-based CHMO repository, we would have continuous integration workflows that are in line with OBO Foundry principles and other best practices, like keeping the editor file separate from the various release files, automatically creating release files from it, and running reasoner-based consistency checks before each release. And now, unfortunately, only recently, we finally had the chance to put some resources into starting this migration effort, and I'd like to give you a little update on how far we are with this. Having to document our work in order to train more people and responding to the OBO community's request for better documentation on migrating ontologies using the ODK, we first started by writing a how-to article for the OBOK using CHMO as our primary example. The OBOK is a collaborative training resource by the OBO Foundry community, hosted on GitHub, and it is supposed to make things easier when it comes to working with ontologies and using ontologies. And it's quite easy to improve the OBOK because it's based on GitHub, so we could make a pull request and add this documentation. And together with already existing great tutorials and how-to articles, this documentation will hopefully help anyone with some basic Git and command line knowledge to do a similar ODK migration. So if you have such a use case, please, we encourage you to use this documentation and provide feedback where it might need improvement. Because after all, having a good comprehensive documentation is essential for us when we need to have people understand how to build ontologies that depend on importing terms from other ontologies in a logical and consistent manner. Having said that, let's get to the actual migration part. So seeding an ODK-based repository in our fork was straightforward. All we had to do is provide a configuration file for ODK in which we specified the ontology's main metadata, where under which GitHub account it's supposed to be published, which ontologies need to be imported, and what formats are supposed to be provided as release artifacts. And then as a next step, we copied all existing CHMO terms from the current release file into the new CHMO editor file that was generated by ODK. So these steps are really straightforward using ODK. And now we are in the middle of building import modules for CHMO. For those of you who are familiar with the term, think of them as being something like software libraries when you do code development. Where to avoid bloating your code base, you would only import those parts of a library that you reuse that are actually only relevant to your project. And similarly, in ontology development, you don't want to import an entire external ontology if you only need a few specific terms from it. So you build import modules in ODK, which allows you to create slimmer subsets of these external ontologies containing only the terms you're interested in. And ideally, you would just simply provide a list of areas of the terms you're interested in, and then ODK would use robot commands to extract the slimmer subset, and thereby also ensuring that all related axioms of these terms are copied as well to maintain the original meanings of these terms. However, this step can become more complex and time-consuming in practice, depending on how the external terms have been previously imported into the ontology that you are migrating. And in CHMO case, in the case of CHMO, where terms have been manually imported previously, we face some specific challenges. For example, CHMO initially imported terms from the physical-chemical process ontology REX and the physical-chemical methods and properties ontology FIX. And then later, these terms were replaced by equivalent terms defined in CHMO itself. However, instead of deleting the old recs and fixed terms, they were marked as deprecated, likely out of caution. But it's important to note that terms should only be deprecated within their own namespace and never elsewhere. So in order to fix this, is quite easy. We just drop these import modules. And then when it comes to reusing the same upper level ontology as many or other OBO Foundry ontologies, we can import the full BFO 2.0 classes only version, which would resolve issue number 1. However, CHMO also currently uses some presumably outdated BFO relations, so we could not replace all of these relations with their equivalents from the relation ontology, like has part or has participant, and thus kept them so far within the CHMO editor file. And we will look closer into this in a subsequent PR, and maybe need to think about if we should rather use the BFO 2020 version, which also includes relations alongside with row. And then other issues like issue number 7 should very easily be fixed just by using ODK and having auto-generated release artifacts and specifying in our config file that we would also like to produce a JSON LD release alongside with an OWL and OBO release. Other issues, like for instance, this one highlighted here, which is about the injection of some classes into the OBI hierarchy, can be rather fixed easily, partially at least. For instance, if we, when specifying the OBI import module, this device class will automatically be subsumed under the BFO material entity as it is in OBI. Of course, the question whether a portion of material is really something distinct from the BFO material entity class remains to be discussed within with chemistry domain experts. While the other issue of injecting extraction and elution into the OBI hierarchy remains to be an issue that can be resolved by requesting these terms rather in OBI and then obsoleting them in CHMO. But I just wanted to say that such an issue has been discussed in a similar issue where it was that dealt around lab devices. And for me, the question would rather be, wouldn't it be better to have a import module that can be shared by many ontologies when it comes to such general terms, because many might not know that such general terms are actually defined in OBR. And if we were to have a module with its own Perl that can be imported for such domain neutral terms, and such a module having a domain neutral name, I think it would be better. We will discuss this in the context of Nfdi4, the Nfdi4 ontology, if it's maybe a place to provide such a thing. And as a last example of the challenges around building CHMO import modules, I wanted to highlight that CHMO currently reuses only 21 terms from ChEBI. But unfortunately, the default robot extraction methods pull out too much from ChEBI when building an import module. So we have to yet further analyze why this is the case. It might be due to the fact that CHMO imports classes from the atom branch of ChEBI and wrongly subsumes them under the molecular entity branch. But it could also be due to the fact that we have sometimes really fine-grained axiomatization in ChEBI and sometimes some gappy axiomatization. So right now it seems like we would have to use custom robot code, which is also possible within ODK, to build a more slimmer ChEBI module. Yeah, but once we have more insight, it might be interesting to see if we can maybe have rather also a more easier to use ChEBI module being released by ChEBI itself, which could help in this regard. And then coming to a little different topic is, like Oliver already referred to, last year we presented a white paper that is now being published on ChemArchive about the use of the IUPAC Gold Book as a source for textual definitions in chemical ontologies. And we're still looking for constructive feedback, so please feel free to reach out. And since CHMO uses the Gold Book quite a lot for as its definition tools for many of its terms, we now started to systematically checking if we could, or that we can apply what we presented in this paper also on CHMO. And once CHMO is migrated to ODK, this would be then one of the next PRs coming up. And with this, I would like to switch to saying a few things about the development of the vibrational spectroscopy ontology Vibso. Since our last workshop, we had one new pre-release made in last September, in which you can see the progress that we have made. It's since we are still only 2 active developers with a lot of other things to do within NFTI, this progress is rather slow but steady. And in the hopes of getting more interested in contributing and helping us, and to make it easier to discuss ontological aspects of this ontology with our domain experts, we focused a lot on improving our documentation, and now explain in more detail the design patterns, mostly coming from OBI, but also from OBO in general, on which we depend and which we need to extend in the case of Raman spectroscopy being an extension of the OBI assay pattern. And yeah, it's now there. Feel free to also check this out. I believe that it might be better to also have such a documentation rather in a more central place, maybe something like the OBOK, because it is not just of interest for our specific use case in the vibrational spectroscopy ontology, but also in other ontologies that deal with assays. And we feel like this could be a little bit more out there, such patterns. And yeah, also we are going to contribute to a paper that is being currently being written mostly by the domain experts from the Charisma project, and we would like to contribute a section in which will deal about the use of ontologies and in general, and Vibso in specific, in order to facilitate linked open data in the Raman domain. Yeah, and lastly, content-wise, we are still working on classifying the various Raman spectroscopy assay types using axiomatization, because currently the definitions we find for this in CHMO are not axiomatized, but we need more axiomatization for defining the various kinds of Raman spectroscopies according to the ISO specifications. For instance, to be able to group them according to parameters like the excitation wavelength that was used. So we usually have something like a grouping for ultraviolet Raman spectroscopies, for instance, or when it comes to the leveraged, respectively implemented Raman effect, like Stokes or anti-Stokes, or grouping by optical pathway settings, like confocal Raman spectroscopy. And we currently have a proposal in a PR where we defined Raman effects like Stokes and anti-Stokes Raman effect in order to define very basic Raman spectroscopies, but we need to discuss this further with the OBI developers early next year and Holland from CHMO. Yeah, with this, I would like to thank you and hand over to Ura.
Thank you, Philip. Can you hear me?
Yes.